Well, Kelsey, I just turned on the recording. Um, it's up if you want to go through something. Just let me know.
Okay. Let me see. Lesson 8.1, do you think you could go over, it doesn't matter which one, but either 3 through 13? Those ones kind of confused me.
Okay. Well, let's just take a look. Let's start with 13.
Okay.
And I got to get there. 8.113. All right. So we've got this picture of a line up on the top there with points A, B, C, and D.
Mm-hmm.
So here's how this works. Segment AC would look a lot like that first bar I made there from A to C. See that?
Yep.
Hi, Leah.
Hi.
We're looking at number 13 on lesson 8.1. Kelsey asked a question on that. Kelsey, and then the second thing is that's the CD, segment CD. I drew a version of that right there. Okay?
Mm-hmm.
Now, if you would squish them together vertically, that would tell you where they intersect.
Okay, so just on C?
Yep.
Okay.
That's correct. We can take a look at 5 too. 5 looks like this. You got your A, B, C, D. You got your AC again. And this time you have ray BC, which means it goes forever to the right through point C. This time you're supposed to do a union. What does that mean? You squish them together, but I don't want to overlap this time. I just want, what do you have? Well, you've got a ray starting at A and going on forever then, correct?
Yep.
And those are just 3 different ways of naming that ray. Ray AB, ray AC, ray AD. Those would all be correct.
Okay.
They're all the same ray because rays go on forever. So we looked at a union and an intersection, and that pretty much covers the, the connectors.
Okay. Yep. And then I also had number 67 on 8.1.
Yeah, there's very little algebra in this course, but this is a problem that maybe uses a little bit of algebra. So you've got your picture up there in the corner with 4 angles where the 2 intersecting lines are. I guess I didn't quite name them the same as in the book, but that's okay. So what's the measure of angle? What happens when you put angles A and B together? What do you have?
180.
Right. And
so that one you didn't really have to do anything for, right?
What's that?
And that one you don't really have to, you just figure out it's 180.
Yeah.
Okay.
It makes a straight line. Yep. And then in the what I list as number 2, what happens when you add up C and when you put C and B together?
Oh, same thing.
Get a straight line, a different one, but you get a straight line. Now, here's where the algebra comes in. Since both number 1 and number 2 equal 180, then they must be equal to each other. So, here's the part up from number 1, measure of A plus B.
Mm-hmm.
Here's the part from number 2, measure of C plus angle B. Since they're both equal to 180, don't they have to be equal to each other?
Yes.
So that's all I did in that line.
Okay.
And now, notice there's an angle B on both sides.
Mm-hmm.
So we could just subtract that from both sides, and what's left?
A equals C.
Yeah, by the way, that little M stands for measure of angle A equals the measure of angle C. And I believe, now, where is this problem? I believe that's what they asked you to find out. Yeah. So all I did was, you can see I mimicked what was in the book, but I filled in the blanks. Now, I promised you guys there wouldn't be any proofs in this chapter, and I'll admit this looks an awful lot like a proof. But there won't. You don't have to worry about this on the test.
Okay.
But it should make sense to you.
Yeah. Okay.
So it's kind of lonely on Monday night.
Was it?
Yeah, like I was there alone.
Oh no.
Yeah, well, hey, I'm not looking for sympathy. I was just it was just kind of interesting. My my 2 favorite guests were not there.
Yeah, I'm trying to catch up with one of my other classes, so I wasn't able to make it.
I know you guys have a lot to do.
Yeah, I'm in that really tough diversity class right now. So.
Yeah.
Yeah.
No, you decided not to join me while in class.
Exactly.
That's a good idea.
Yeah.
You're dedicated.
That keeps both you and I out of trouble.
Exactly, right.
Yeah.
Okay.
Now, I don't know, you guys, it's been a while, but if you want, we can look at questions on that last online test, the test on chapter 3, if you want.
Sure.
I'm good with, we can keep doing this. This is valid. This is maybe more, well, they're both valuable. So whichever.
Yeah, I did have quite a few questions from, it was, I was working on 8.6, a lot of the, like specifically like 8.67 and working with traversability. I don't know, for some reason it's a little bit tricky.
Okay.
So.
Well, let me, so you started working on some of the assignments on that?
Yeah.
Okay.
We're required to do that this week, correct? I'm on the right.
Yeah, we're a little bit off schedule. We're a little behind that.
Oh, okay.
Anyway, here's the deal.
What?
We've had to adjust several times on how things are going. This is week 8. Next week is week 9. Week 10 is our last week. So
we have a week 10. Okay, I thought we didn't. Okay.
Well, I know it doesn't show up on the schedule, but it's a 10-week class.
Okay.
So what's going to happen is during week 10 is when the notebook on chapter 8 and the online test on chapter 8 will need to take place.
Okay.
So how you schedule chapter 8 in these 3 weeks. I'm not so fussy about what gets done when. So, but anyway, so in other words, we're not quite as rigid as the schedule shows online. But
thank you.
yeah. So, yeah, let me pull up the 8.6 here. I mean, you said 8.7, right?
I'm sorry. No, 8. You're right. 8.6 and then number 7. Yep.
8.6, but that for me is in those 7. Okay, got it. Okay, well, yeah. Do you remember? Do you remember what the traversability rules are? I mean, it comes down to.
If there's
Go ahead.
0 or non, it is traversable, correct or no?
Yeah. What did you say? 0 or what?
0 or 2.
Yeah, that's correct. I'm just trying to find the page in the book where this is. Oh, it is 8.6. Okay. Yeah, it's on top of page 566. If you've got all odd vertices, no odd vertices, then it's traversable. And if you have 2 odd vertices, it's traversable. If you have more than 2, yeah, so like you said, 0 or 2. Okay, so let me get this right.
I think on 7, there was 5 even vertices and then 1 odd, but then I put down that it was non-traversable, and I think they say it.
They agreed. Okay, and that was number 7?
Yeah, that was number 7.
Let's do number 7. Okay. So 7, you've got this picture. I have to stretch that a little bit. There we go. Okay, so what do we got for counts at each vertex? This one has 2 paths coming to it. This
Yes.
one has 3.
3.
This one has 2.
2. This has 6, right?
Yep.
Okay.
2.
2. Oh. 3.
See how that one has a 3 there?
Yes.
So how many odd vertices do we have?
We have 2 odd.
So this one is, yes, traversable.
And I heard in the video that you're not really concerned about like where it's coming in and going out. It's more about, yes,
Yeah.
it is traversable, or no, it is not.
Yes, so that is correct. So the book, I know, wanted you to go ahead and tell me where do you begin and where do you end, and you're right. I'm not interested in that. All I want to know is, can you tell if the network is traversable or not traversable?
Okay. That makes sense. try 11 possibly on that same.
Yeah, 11. Yeah, well, this is where, okay, where you have to change it. It's almost like a floor plan of a house.
Okay.
Okay. So I got to show you how. I know you're not going to make any sense out of that diagram, so I am going to reconstruct the diagram.
Thank you.
So the picture I drew there is of the network in the like house plan on number 11, except that I drew in little doorways in every what do you call it? Every one of the walls, so to speak. Okay. Now there are 4 rooms, A, B, C, and D. So what you do is you just make a dot for each room.
Okay.
And then now using the doorways, you have to mimic all the paths. Okay, so where can you go from room A?
You can go outside.
You can go outside. We need to do an outside room. So yeah, I call that E in this particular case. You can call it O or whatever. Okay, so from A, you can go outside 2 ways. So I would draw that like that. Okay, you can also go to room B. And, oh no, you can go outside 3 ways, can't you?
3 ways, yeah.
Okay, there we go. Where can you go from room B? Well, you can go to A. We already have that. You can go outside. You can go outside 2 ways. And you can go to D. And you can go to C. Where can you go from room C? You can
outside.
Go C to D. You can go outside, what, 2 ways?
2 ways.
So 1, 2, and then finally room D. Okay, D, you can go to B and C. We already have those drawn. You can go outside 3 ways. So you get the idea here. I know this is getting awfully messy, but so you've got a drawing, and that's what the network looks like. And then, I mean, this is a little bit smaller drawing of the same thing up here. So then you got to run a count. This is kind of messy, so we won't look at that. But the count for me at E turned out to be 10. A was 4, B was 5, C was 4, D was 5. How many odd vertices do we have? Just 2. So yes, it's traversable.
Yeah, 2.
Just 2 5s. Everything else was even. 10, 4, 4. I just wanted to show you in red how I made.
So on 13, 15.
Okay, I got half of that. 13.
Mm-hmm. Oh, on 13, 15, and 17, are you just asking us, basically, you're just asking if it's reversible or not again?
Wow, I'm only getting about half of your stuff here. No, getting the phone call. I have to ignore.
Sorry.
No, my apologies. Okay, so determine whether it's possible. So really, you're only answering the first half of the question. Is it possible to go through each door once? So what you have to do is you have to make a drawing.
Mm-hmm.
Let's see, this is number 13. So again, I looked at the book. Where can you go from A? You can go to D. You can go outside the O. and you can also go to room B. And anyway, I just went through and I made this diagram.
Yes.
Now, run your count at each vertex.
Okay.
What do we have? We've got all evens except for 2 threes.
So the 2 3s make it traversable.
That's exactly correct.
Okay.
And you're right. The second half of that question, I'm not interested in.
Got it. So I noticed that like 23 and 25, they say like state the parallel postulate in Euclidean geometry.
You weren't supposed to do that one. You don't need to do 23. And maybe that means I misstated the assignment. I don't know. Here, let's take a quick look.
Okay.
Yeah, I don't know if we have to go look at it. But assignment.
Okay.
There we go. Yeah. Anyway, you don't have to do that one.
No. Okay.
The parallel postulate just says if you've got a line and you've got a point off of the line, there is only one line through that point off of the line that's parallel to the. But you don't have to worry about that.
I see.
That's yeah. And I can see I did not make that clear when I wrote out the assignment. My apologies.
Okay, so you want me to do 33 and 35 on that one too? Okay.
Yeah, you should do 33 and you should do 35. That is correct.
Okay.
No 23, no 25. Okay, but how about back to Kelsey?
I'm sorry, I did not get to 4, 5, 6, and 7.
You were wondering what in the world is traversability?
Yeah, I'm like trying to follow. I'm like, but wait, why does it go 3 times? I don't know.
Yeah, traversability. Traversability means can you go to every point without doubling up on any? That's kind of you'll see. It's
okay.
That's way too simple to do it in that few words, but
yeah,
when you view the video, I think it'll make sense.
Okay. I had number 29 and 31 on 8.2.
All right. So 29 and 32?
Mm-hmm. Or 31.
29 and 31?
Yep.
Okay. So here's number 29. So on the top there, I copied the diagram. I got to get to that page here. Yeah. So I've got the picture of the triangle with PQ being parallel to AB. And then in number 29, they told you that AP was 3. So you see I wrote the 3 in there. And PC is 4. So I put the 4 up there from P to C. and BQ is 6, but then they didn't tell you any of the other, they didn't tell you what BC was. And so this part, let me change this to a red pen here. So this part right here is not showing. Now, the first thing you got to realize is triangle CPQ on the top, CPQ, is similar to triangle CAB.
Yep.
Okay. If they're similar, then their sides should be proportional. The problem was, what am I going to name this thing up here that I just circled? And they're looking for BC, so that's what I called X out here. Can you see that if the whole thing is X and the bottom part is 6, then this part has to be X minus 6?
Yep.
Okay, well then you can set up the proportion. The left side of the little triangle is to the left side of the big triangle. So left of little, 4, is to left of big, 3 plus 4, 7. You see that?
Yep.
As the right side of the little, X minus 6, is to the right side of the big, X. So that's really the key to solving this. How do you solve for proportion? Cross multiply?
Yep.
So 4 times X, so that's where this equation comes from below there. Sorry, it's kind of crammed. I'll make it a little bigger here.
That's okay.
So 4 times X equals 7 times X minus 6. Don't forget, you got to use the distributive property. 7 times X is 7X. 7 times negative 6 is negative 42. Then you got X's on both sides. Got to do a little bit of algebra. I did it by subtracting 4X from both sides. Anyway, you can finally get it to the point where you can solve for X. And you find out that X is 14. Now, X, where did they ask for CQ?
They didn't.
Oh,
so we had to figure that out.
That was, I must have been showing somebody else. So anyway, 14 is what you were supposed to find out.
Okay.
So there's a fair amount going on there. That proportion is extremely important. Once you get that right, then you do the cross multiplying and a little bit of algebra 1 to get it down to the value of X. You said 31. Same kind of a deal. This one may be a little bit simpler. This time they gave you AP was 2. They gave you BQ is 3. BC is 5. Oh, so in effect, they just told you CQ. But you don't know PC. So that's what I called X, because that's what you were supposed to find. Here again, the left side of the little triangle, X, is to the left side of the big, X plus 2, as the right side of the little, 2, is to the right side of the big, 5.
That makes sense.
And then cross multiply. Remember, watch out for the distributive property. Solve for X. X turns out to be 1 1/3 or 4/3.
Couldn't you do 2/3 equals X2 or no?
What?
Could you possibly do like 2/3 equals X2?
What do you mean 2/3 equals X2?
Let me see.
What do you mean? What's X2?
Well, okay, so if you want 2 over 3 equals x over 2.
Oh, so that's what you meant by x2.
Sorry.
Yeah, x over 2. Yeah, you could do it that way.
Okay.
But here's what only thing I caution you on there is 2 and 3 are actually not pieces of triangles.
Oh.
I mean, they're pieces, but they're not full triangle sides.
Okay.
And so what I was trying to do is go left side of little triangle is to left side of big. I was using the triangles because that's all we were really taught. Turns out what you said will work. Here, let's just do it real quick. So
okay.
you said 2 is to 3 as x is to 2. Yep, same result.
Okay.
So that's why I didn't do it that way, but it turns out that does work.
Okay. It seems like the first way you did it is safer.
Yeah, that's not a bad way to describe it.
Okay.
Yeah. I'd like to stick with triangle sides because really, what did we learn? We learned that if two triangles are similar, then the corresponding sides of the triangles are proportional. So I wanted to stick with triangle sides.
Okay.
So anyway, yeah. Obviously, if you had what's on red there, in the red there on your paper, that would be correct.
Okay.
So yeah, thank you for asking about that. And now you know why I wrote it out the way I did.
I wanted to mention on Moodle, it doesn't say to go to 35 on the other lesson that we were discussing. It just said to go to 31. I'm thinking maybe it says it on your thing, but not on mine.
No, our Moodles should be the same.
Oh, okay.
What lesson was that again?
So that was 8.6.
Yeah, you're right. It says 1 to 31 odds. Go with it. That's fine. Go with that.
That's fine. Okay.
But even that was wrong because I told you didn't have to do 23 or 25. So obviously I got a few little errors there.
Got it. Okay.
Yeah. Just as I was going by week 9 here, and since you asked me a question about week 8, I just noticed that the last presentation for you guys to view is called the divine proportion. And it reminded me that, what was it? Was it just Leah? Or it might have been somebody else other than you two who didn't put any notes on the presentation in their notes?
That was me, I think.
Okay. So all I'm expecting is like, I don't know, a third to a half a page, something of, just showing, I watched it and I thought at least a couple things were worth putting down. Yeah.
Okay.
That's what, okay, good. So, another comment. I mean, this chapter 8 test, boy, if you guys go look at that, the due date is a year ago. Okay.
I missed it.
So you just so you know, you're both late.
Darn it.
I have not changed that yet, and that's in the distance. But anyway, that'll be like I told you. Probably what I'm gonna go with Thursday. I don't know. I got to go with something during week 10, and I'll come up with that. So, and then also I haven't listed the notes for chapter 8 yet. This is going and looking at review notes, but I mean, where you hand in the notebook, that's got to be put in there too. So, I have to do that. Yeah. Oh, sounds like Leah might. Did you get to the iterates yet? Did you do did you do lesson 8-7?
So I listened to all the videos, but I don't think I've gotten to
okay.
The fractile parts. Like I listened to the lesson and I think I kind of got it. I just haven't done the homework for 8-7 yet. So.
Yeah. Anyway, when you do that, do you see under lesson 8-7 here, you see where it says iterates Excel file on my screen here?
Yeah, that's where you're going to insert the decimal numbers.
Yeah, that's a spreadsheet that will help you do all this calculation. I don't know.
Okay.
That's where that is.
No, it's interesting because I have a friend who does a lot of fractal work.
Oh, really?
With his visuals, and he spends hours and hours on it. So I've never understood it. So it kind of helped me understand a little bit of what they do. So.
Yeah, that's actually, I talk a little bit about the graphics, the pictures. Yeah. I didn't realize it, but a lot of modern day movies use fractal scenery.
Huh.
So would you believe when you're watching movies that you're actually looking at mathematics, a mathematical background?
No.
Yeah. Well, hopefully you will after you get done with that lesson. It is kind of interesting. So it's hard to believe, but let's see. We only have 2 more weeks of.
Wow.
2 more weeks of class.
Oh wow. So then, am I, Leah? Are you technically early on your stuff, and I'm technically on time?
She's a little bit early.
Okay.
But she's she's online in line with. She's actually a little bit ahead because what she's doing originally was listed as week 8 stuff.
Okay.
And technically, well, and that's where we are. But I mean, you're so because our schedule is a little bit retarded from that, Leah turns out to be ahead.
Okay. Because then next week, then we'll go over the 4 or 5, 6, and 7, and then we'll do practice test.
Yeah, the rules are we'll go over anything you want to.
Okay.
Of the week. Yeah, but that practice test, big time, in our last week. Yeah.
Okay.
Yeah, I'm sorry, Kelsey, if I'm going to.
Oh, that's okay.
I think what I did was I didn't realize the 10th week was there, and I kind of freaked out. And I was like, I gotta get this done.
I know. I'm like, I felt like I was kind of behind, but
no, I guess you're on track.
I
guess so.
You guys are both fine.
Okay.
Wow, we surely didn't want you to apologize for being
right.
That's wow. That's some apology. You don't have to worry about anything.
Sounds good.
Do you think that we could actually do lesson 8.2, number 37?
Sure.
.3 was really easy.
Is that right?
Yeah.
Oh yeah, perimeter and circumference. You're right.
Quite
yeah, that should be pretty easy. You're right. Okay, here's 37 on 8.2. Now, you'll have to excuse my grade school artwork here.
That's okay. It makes sense.
Notice my grade school throw a sun up in the top left corner.
Yeah.
Yeah, it's pretty corny. Okay. So we got a telephone pole, which is supposed to be the left side of this triangle where it says X equals. Okay, so that's my telephone pole. The sun's coming down and shining, and it casts a shadow. I guess it's not the telephone pole casts a 30-foot shadow. So you see how the shadow is on the ground down here?
Yep.
At the same time, a 5-foot fence post casts an 8-foot shadow. So that's the second little triangle here. Now, because the sun is what? Almost infinitely far away, the angles are going to be equal. And that's going to make the two triangles similar. Okay. Well, because they're similar, you know what we can do. We can set up a proportion.
Yep.
Proportion. So the fence post 5 is to the height of the telephone pole, which we don't know. So I call that X. As the shadow of the fence post 8 is to the shadow of the telephone pole 30. And then from there, you know what to do. You just cross multiplying.
I guess I didn't realize that it was just a proportion. I don't know why it tossed me.
Yeah, this one took, you had to think about it a little bit, but because the sun is 93 million miles away,
right?
The angle has to be the same, and yeah. So anyway, so that's how that one gets finished up then.
Okay.
I did not do very well in grade school art. I even remember my teacher making some comments about that, but
could we discuss 45 on the same lesson also mentioned?
okay. I heard about every other syllable. Which one?
Oh, 45.
Got it.
Thank you.
Okay, 45. So there's a picture in the book, and they tell you that AD is the same length as BC. That's what those little single notches mean, that they're equal length. And then they also tell you that AC is equal to BD. Those are my little 2 marks. Can you show that the 2 triangles are congruent? Yeah, this a little bit shady because this is kind of a proof again. But I mean, you've got AD matching. So you see we have 2 triangles that are crisscrossing each other there. ADC and BDC. Okay, so they match up. AD matches with BC, AC matches with BD, and they both have the same bottom, DC. So therefore, all 3 sides match up. That's enough to prove congruence. We used to call that side, side, side in geometry. That's what the S. So again, that's a little bit off limits, but for you on the test, but that's how that one goes. So it's kind of a proof.
Something.
And proofs you aren't going to be responsible for.
Okay.
Because I mean, otherwise we'd have to go through all the geometry theorems. And we're not, as you probably can tell, I'm not going through those. So we're not expecting you to. So actually this problem isn't totally lined up with my testing.
Okay.
So did you guys see that your extra credit got put onto your scores?
Yes.
Did you check that, Leah?
Yes. Thank you.
Well, what I mean is I want you to check, check to see if that, I like that when the students check on that and make sure it's being done.
Could we do 41? I think on 41, it was difficult to figure which sides go with what sides.
Yeah, that's kind of a crisscross problem there.
Yeah.
So here's the picture. It's pretty much the same picture that's in the book. You got the tunnel up on the left, this length up here. And find the length of the tunnel to be bored. So in other words, what's the length of the tunnel? That's the question. And you've got these other distances given. The 540 meters. Yeah, I just copied those. Okay, now here's the odd thing here. These two triangles, one on the left and the little one on the right, are actually, again, guess what? Similar. And the reason? Well, the ones with the two little rings here, those are equal because of a geometry theorem called vertical angles. At a vertex, angles opposite each other are always equal. Why are these two equal? This one here and this one down here. Well, because they told us in the book. See that? They've got a ring there. Well, if two angles of one triangle are the same as two of the other, that means the two triangles are similar. And if they're similar, the sides are proportionate, except it's twisted. So you got to be a little careful. So this side of this triangle is to the opposite side of the little triangle. So 540 is to 18 as the tunnel is to the 20. So you see why it's twisted? Because the single notch is on the opposite side of this triangle as the single angle is up here.
Yeah.
Yeah. So that's the only tricky part. 540 is to 18 as T is to 20.
Okay, I think that's why I got it wrong the first time, was because I didn't match the correct sides.
Yeah, it's very easy to do that. Yes, I get it. Anyway, then you got some bigger numbers, but you just cross multiply and solve.
Okay.
Maybe I didn't make that clear, but 18T, I did two steps. Right here, I did two steps, but maybe I shouldn't have. So anyway, when you cross multiply, you get 18T equals 540 times 20, or 10,800. And then I also divided both sides by 18. And then you get your answer, 600 meters. By the way, I mean, in effect, this is, have you ever wondered, when you're at an airport and you're going to take off, the pilot has to know what the cloud ceiling is. In other words, how high are the clouds?
Mm-hmm.
And they don't run a tape measure up there. They actually do similar triangles to calculate that.
Oh, wow.
So anyway, or if you wanted to find the height of the Great Pyramid, you don't have to crawl up it to, in fact, they wouldn't do it anyway, because how could you drop down to find the vertical distance? You'd have to go flying off the side and go Yahoo, and then hold the tape down quickly, before you come down and die. Yeah. Anyway, similar triangles allow you to find heights, and this, like here we found a height of the length of a tunnel without digging into the rock. Yeah, comes in very handy.
Can we do 8.4, 21?
Okay. 8.4. I'm going to have to load a file for that.
Okay.
Okay, here's 21. 8.4. So we got the picture in the book. I copied the numbers there. Although hard to read, that's 120 down there on the bottom. Anyway, so it says if the estimated cost of the wall is $12 per foot, what's the estimated cost of the wall? So in other words, how high is W? So in a right triangle, how does one find the missing side?
C squared equals A squared plus B squared, or no?
Exactly.
Okay.
And C is what, the 130?
Yes.
So that's by itself, 130 squared equals the square of the other two added up, 120 squared plus W squared. Okay, so I worked those out and solved for W, and I came up with 50 feet. So that's 120 times 120 gives you that 14,440, and 130 times 130 is 16,900.
Okay.
And I subtracted 14,400 from both sides. W squared equals 2,500, and then just take the square root. So 50 feet. Now, if it was $12 per foot, 12 times 50, $600.
Okay.
Yeah, you were right. That's the Pythagorean theorem that needs to be used here. A squared plus B squared equals C squared.
Do we have time for 37?
Sure. On 8.4? On 8.4? Leah?
Yes.
37 on lesson 8.4?
Yes.
Okay. Yeah, now this is really over the top. This is a stinker. Okay. But okay. I mean, this is like triple extra credit if you get this right. Okay.
Okay.
But I think it was good for you guys to work on. So here it is. Show that the area of an equilateral triangle is s squared times the square root of 3 over 4 if the side of the triangle is s. And then they give you this hint. If you draw a perpendicular to one side, it's got to bisect that side when it's an equilateral triangle. So you see the picture off to the left.
Mm-hmm.
The three sides are S, S, and S. Okay, and I drew the perpendicular like they said, H, and then it bisects that other side. So this side right here is equal to this side. So now, do you see that we can look at half of that and call it a right triangle?
Mm-hmm.
Yeah.
And that's, okay, now it's time to set up the good old Pythagorean theorem. So, one leg, h squared, plus this leg, that's half s, or s over 2 squared, equals the hypotenuse, this long guy, squared. Do you guys see that? So, one leg, h squared, plus the other leg, s over 2, this is half, because this whole thing is s, this is s over 2, that squared equals the remaining side squared. Well, then what I did is I took this and I worked it out and I solved for h. I don't know if we have time to do that, but anyway, h comes out to, see away at the bottom of this box, the square root of 3 times s all over 2. That's that. We just found out what h is in terms of s.
Okay.
Now that you know what h is, now how do you find the area of a triangle? Base times height divided by 2.
Mm-hmm.
What's the base? S. What's the height? That's this thing we just found over here, square root of 3 times s over 2, and then that all over 2. And if you put it in the right format, guess what it comes out to? What the book asks you to find, square root of 3 times s squared over 4. But, yeah. So, like I said, that's way too hard for a test question, but it's a good question.
Okay.
So what I'm trying to say is you don't have to worry about that on the exam, on the test. So somebody else got a question? Or do you have enough to chew on for another week?
I think I'm good.
Okay. How about Leah? Do you have another?
Yeah,
Go ahead.
I think that's enough for now. I think my brain is just like.
Yeah. I didn't want to cut you off. I'd be okay. I don't care if that it's after 8. I just
Yeah.
You're right. There's only so much your brain can take at once.
No, but this was helpful, very helpful.
Oh, that's good to hear. Well, take care. I'll see you probably on Monday. I'll see you. You know what I mean, electronically.
Right.
Okay.
All right. Thank you.
Thank you.
Bye.
Good night.